Hey everyone, we're here with Bruce Davie, obviously one of the founding fathers of, I would call it, network virtualization at the moment. Obviously you have a big history in networking, also with your Cisco background. We've been talking a little bit earlier about new distributed services that VMware is introducing into NSX. Can you talk a little bit about the services that we're introducing?
Sure, and I guess the first point to make is just that distributed services are really, I'd say foundational to what NSX is all about. And so our sort of long-term vision is just everything that's implemented in networking should be distributed out as much as possible. And so we've had distributed switching, distributed routing, distributed firewalling for quite a while. And then in 6.2 we just announced a tech preview of distributed load balancing. And then we've also talked about we will talk about in tomorrow's keynote about distributed encryption. So this whole idea of taking network services that in the past you might have thought you would find them in a box, now you'll find them not only implemented in software, but fully distributed all across the data center. And it's an extremely powerful sort of technique.
Yeah, obviously we're leveraging the compute power that we have in each and every node for the functionality that you're talking about.
Right, so that's certainly one of the first things, is that because you get to do a little bit of these distributed services in every hypervisor, it scales out as your applications scale out. And so the more workloads you have, the more services you have, the more firewall capacity you have. So you can build a terabit firewall without any physical devices whatsoever, just using your native server capacity. So it's incredibly scalable.
Yeah, that's amazing, because if I want to buy a terabyte firewall in a physical format, that's going to cost me a pretty penny, I think.
Yeah, and fill up many racks in your data center as well. So yeah, it's a really powerful thing. But I guess the other thing that I think is worth emphasizing is that because we distributed the services all the way out to the hypervisor, we're able to take advantage of all the information that we have in the hypervisor about the workloads. So for example, we can create firewall policies based on the name of the VM or the OS that's running on the VM. So effectively leveraging contextual information that is in the hypervisor to make the policies more high level and more intelligent. And you can even create policies before a VM has ever been instantiated, and then that policy gets put in place after the VM is created, because you know all these things about it. So it's a very different world from one where you would go in and create policies based on IP addresses, for example.
Yeah, and I think also if we have an intelligent security solution on the virtual machine, for example, and we notify or we see that, for example, someone posts credit card data on that machine, we can immediately change the security policy. Is that correct?
Yeah, exactly. So the more that you can figure out what's going on within a VM, and then have different services communicate with each other, you can do all kinds of clever things where you change the topology because you discovered that a particular OS was vulnerable. You can have different services communicating with each other using tagging of the VMs, and very dynamically sort of chain services together.
Okay, well, we're talking mostly about virtual machines now. You obviously mentioned the distributed services. One of the most popular so far is the distributed firewall and the microsegmentation use case. Is it possible to extend that to physical workloads as well?
It is, or at least it will be. So we've been working on that. I got involved in that over the summer, and so maybe worth as a quick sketch to sort of show what we're doing, and forward-looking disclaimers apply to this little bit of discussion.
Perfect, thanks.
So we've got this capability today to take a hardware VTEP, VXLAN tunnel endpoint, and have it controlled by NSX. And so today we use that for, say, taking some VMs and connecting them to a physical workload. And so you can build a virtual network where, say, these VMs and this physical workload appear to be on the same L2 subnet, even though they may, in the real world, be on completely different subnets. And this is done with NSX communicating with the hardware VTEPs using OVSDB.
And by hardware VTEPs, just explaining for the audience, you mean the integration that various hardware partners like Arista, Brocade are working on with us.
Exactly.
To extend the virtual network.
Yeah, that's right. So we've done this with, I'd say, the vast majority of the hardware switching companies now have implemented the OVSDB protocol on their hardware, and so it gives us this ability to, say, take a top-of-rack switch from any of our partners and have it be a fully integrated part of an NSX deployment. So today, what we've announced as part of 6.2 is the ability to do this just for bridging traffic from the physical to the virtual, but we're actually working on two new capabilities. One is to do distributed logical routing in the VTEPs, and then the other one is to extend security policy out to these VTEPs as well. So let me just sort of show you how this would work. So in the logical space, we'd have, say, a couple of VMs and a physical device. And we really like to have microsegmentation applied to all of the traffic that's going between these. So you want to apply security policies sort of here, here, and here. So NSX lets you express that desire to have this security policy, which might be something like, this VM can talk to this physical device, but only on port 443 or something like that. So to do that, we can now express that into the NSX API. NSX will go and instantiate firewall rules over on these VNICs, just as it does today, but it will also communicate over the OVSDB channel the exact ACL configuration that needs to be instantiated here. And so you get this ability to build consistent security policy independent of whether your endpoints are physical or virtual.
Perfect, and this will all work, I guess, in software. So if a customer now buys a hardware-capable VTAP from any of our partners, this will also work on those versions, or do you recommend them maybe waiting until we have finally, obviously future disclaimers apply, but what's your recommendation there?
Yeah, so today you can go out and deploy this and get the bridging capability, and everything that I just described is purely a software upgrade. So it's just leveraging the existing ACL capabilities of the hardware and just providing a channel by which NSX can express the policy that is intended by the user and communicate that down to the hardware so they can implement it using whatever ACL capabilities they have in the hardware. So it's a pure software upgrade.
Perfect, thank you very much. Well, Bruce, this is to me a very clear eye-opener that distribution of services is what it's all about, not just for virtual, but also for physical. So great progress on your side. Thank you very much.
All right, thanks very much.